Hello, and welcome to another edition of Groups Without Algebra. I'm Josh, and I'll be leading this session today. So today we're going to talk about groups and subgroups. So what are subgroups? Well, the main idea is that sometimes groups contain smaller groups within themselves. So even if you have a group, that group might contain other groups. So let's see what I mean. So here's a tile from a previous video, and this tile, as you may remember, is a representation of the cyclic four groups. So we can take this tile and go 1, 2, 3, 4. So 4 90-degree rotations, and then we'll go back to the same configuration we start with, in this case the red corner in the top corner. And so this represents 4 elements that you can kind of cycle through and have some kind of symmetry in them, the cyclic 4 group. But what would happen if I take this tile and rotate it 180 degrees and I end up with this blue corner pointing up, and I rotate it another 180 degrees and end up right back where I'm started from? Seems like this could be something that preserves symmetry. And we've already shown that we can get back to the beginning. So we have closure, right? So if I start with, and I only do 180-degree rotations, if I do as many of them as I want, I will always end up back to my original starting point. So could this be something that's also a group? Well, let's take a look. We're going to replace this tile with this handy-dandy tile. So it's the same kind of tile, however, it only has 2 corners colored. It only has a white corner and a black corner, and they're opposite to each other, kind of opposite on the diagonal. So let's talk about this. So if I start with this, and I rotate up 180 degrees, and I rotate again 180 degrees, I end up back to where I start from. So I already have closure on this tile, right? So I already have closure under this operation of rotating 180 degrees instead of 90 degrees. Okay, so what else can I show? Well, let's say I go 180 degrees, so I go from the white corner to the black corner, and then let's say I go the opposite direction. So instead of going clockwise, I go counterclockwise. I end up back to where I start from. So I can undo each operation of rotating from 180 degrees and get back to the original starting point. So this is an inverse operation. If I start here, if I go here and then do an inverse operation, I can get back to where I start from. And that's true whether I start with the black corner up top or the white corner up top. So I've kind of shown that inverses exist, that there isn't, for every element, for every configuration, there is an inverse configuration. Because there's only really 2 elements in this set, right? I can have the white corner facing up, or I can have the black corner facing up, and back to where I start from. So I have group closure. I have existence of inverses for each element in this 2-element group. And if I want to go from black to white, black to white or white to black, I can always do that by adding a certain element to another element. So if I want to start with black, I can add 2 180-degree rotations and end up with black. And if I want to start with white and get to black, I can do 1 rotation, just like this. So I have an idea, I have a concept of group addition. So I have closure, right? Every element can be added to one another to keep things in the group. So I have group closure. I have inverses, and I have group addition. So this is a group. But this is also only a subset of my operations here. So when I look at the cyclic 4 group, which is really like, rotations of 90 degrees on a square in this representation. A subset of those is to rotate 180 degrees, right? And instead of having 4 different elements in that group, if I rotate under 180 degrees, I only get 2 elements in that group. I get a finite simple group of order 2. It's kind of nice. Another topic of a previous video. So this is an example of a subgroup. This is an example of how the cyclic 4 group contains another group using the same operations of rotations. Because again, like a rotation of 180 degrees is really 2 rotations of 90 degrees in the same direction. So this is an example of a subgroup of a larger group. So the cyclic 2 group is formally a subgroup of the cyclic 4 group. So that concludes this video, and that concludes another edition of Groups without Algebra. Thank you for watching.